Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
So welcome to this episode of the Trend Detection Podcast. We're back in the studio again, and I'm really delighted to welcome Richard Jeffers from RS Industria and Rob Russell from Siemens, or Senseye Predictive Maintenance. Today we're going to talk about lots of different topics: maintenance, technology, industrial IoT, and just these guys got lots of experience in that space. So really looking forward to getting into that conversation. So if we start, first of all, with some introduction. So Richard, do you want to kick us off?
Yeah, thank you, Niall. So my name's Richard Jeffers. I work with RS Group, and I head up our industrial data business unit called RS Industria. My background, however, is on the customer side, running factories, building factories and maintaining factories. So I've always been a consumer of data insight, and now I've got into the side of offering it as a service.
Fantastic. And Rob?
Yeah, hi, I'm Rob Russell. I'm the head of predictive maintenance strategy and delivery within our Senseye Predictive Maintenance team within Siemens.
Fantastic. And your background, Rob?
Yeah, so my background, I'm actually a mechanical systems engineer from education, but always worked within software teams in the area of condition monitoring and predictive maintenance, and even considering like through life contracts for aircraft and things like this before starting Senseye back in 2015 with the rest of the co-founders.
Fantastic. No, great to have you both here today. So what I want to start with, as you're both engineers and well-versed in technology and very diverse backgrounds, both of you, which we'll go into. So maybe we could just start about your personal passions for engineering and technology. So what sort of fuels that? Maybe we start with Richard.
If I'm honest, there's never been a time when I wasn't going to be an engineer. I can't remember a time at school when I suddenly had the epiphany and when I want to be an engineer. It was always just, I want to get into engineering. I guess, I moved into operations and maintenance engineering when I realised in my first job that I wasn't a very good design engineer. So therefore I had to go into the application of technology rather than the design of technology.
Absolutely. And Rob?
Yeah, so as I mentioned, I started off as a mechanical systems engineer, but then sort of found my way into software teams. Initially within avionics departments within an aircraft company, and then that naturally sort of led to a career path where being the mechanical guy within the software world was quite useful, where you could cross those disciplines and then bring in the use case to the software team and be embedded within that software environment to keep it sort of grounded as to what people wanted to achieve with software. And then being more of a systems engineer and sort of systems thinking, it was a sort of a natural place for me to stay. And then resulting in being CTO within the Senseye company as we moved on. Probably an unusual CTO because not having a specific software and sort of computer science background, for me it was more about relating it back to the domain of condition monitoring and predictive maintenance where we work with it.
And I guess, because I'm going to set this question up first, and obviously we work very much in the manufacturing sort of space, and I wanted to talk about the challenges first, and then maybe dive into what you've taken from your particular backgrounds to help solve those challenges. So maybe we just start. What sort of challenges, Richard, do you see at the minute in the manufacturing sort of space?
I think looking from a maintenance perspective, although we've understood since the 70s really the fundamental principles of failure and how components fail. Even now, 50 years on, very, very few businesses are actually deploying those methodologies into their daily running of their operations. There's still far too much effort put into time-based maintenance, and not enough looking at leading indicators of failure and doing predictive maintenance and condition monitoring.
Yeah, and Rob, do you have anything to add?
Yeah, I think there's going to be fundamental shifts, and we're in a period of a lot of change going on where there's a lot of new technologies that are coming out. There's a lot of drive for digital strategies, but this is enabling many more new business models as well. So for example, some of the old cliches about availability contracts that we've seen within the sort of aviation sector, we're starting to see this now come into industry. Machine builders now are thinking more about availability of machines rather than selling the machines. we see some of this within even the automotive sector, where you've got companies that are actually providing the facility to build cars to some of the major automotive manufacturers. And that sort of change brings new opportunities. And underpinning it all is, the drive for new digital strategies to become much more data-driven and smarter in the way that we fulfill those new business models.
I guess so. Technology isn't a new thing. I guess my question is around technology adoption, and how has that changed over your sort of career, Rob? Is it becoming more, is software easier to adopt now than it was? Are people more open-minded about software and what it can do for their everyday lives, let's say?
Yeah, and you think about what people are trying to do with like software and even some machine learning and AI technologies is fundamentally about trying to introduce scale and make the human more effective. And if you start to look at, there's a lot of concerns at the moment coming up about the rapid development of AI, but from the sort of perspectives of what we've been seeing and the introduction of that type of software capability to the industrial space, it's about scaling and making humans far more productive and leveraging the experts that humans bring to it, and thinking about the transition that enables that. And it's the move from a lot of very bespoke on-premise solutions to much more cloud-based software as a service type offerings is enabling that change, and it's changed very much in the last sort of 5 to 10 years.
And that you mentioned that a very common buzzword at the minute, AI as well, because Senseye from its beginnings has been talking about AI, but I guess the perception of AI has changed massively. And I guess, maybe I'm putting words in your mouth, but is AI being talked about more by customers when you're speaking to customers now compared to when you and co-founders founded Senseye?
I think you can see sort of within the media at the moment, it's become such a hype and such a buzz term. But when we're talking with clients, it's much more focused now on what are the benefits of the solution. I think it's given that you're going to be using some smart technologies in the background to fulfill this capability. But we always like to bring the conversation back down to what are the actual benefits that it's giving to the business as a whole, and talk about how we can make operations more efficient.
If I just build on some of that from some of the conversations I've had. So, I've recently been hosting a series of roundtables around advanced analytics at a number of different events, and there's some, in both cases that the table topic was advanced analytics, and everybody moves into starting talking about AI and machine learning. And then a couple of things rapidly come out of that. First of all, nobody really understands what that means in terms of deployment of solutions. So actually, if you're not a data scientist, but you're an expert in the domain, then actually they're just buzzwords. They don't really mean anything. The other thing that comes out is actually you can do a lot with some pretty simple tools. And you don't need to, focus on super whizzy, AI tools, because actually simple statistical techniques, can still sort out a lot of wheat from the chaff and allow you to focus very, very quickly on the things that do make a difference. And as Rob said, then putting that insight in the hands of the subject matter experts who can then draw the real conclusions. Because if you have data science without domain understanding, what you get is just rubbish. Because you're not able to contextualize the output. And in fact, one of the customers on one of these round tables, a well-known confectionery manufacturer, shared a story that they'd done some modelling on their factory around failure based on their load of telemetry data and trend data. And what they discovered was that every year the factory stops for 2 days over Christmas.
Exactly. And you mentioned some of those tools that people can use, Richard. Maybe you could just sort of give some examples there. They can start off, maybe as a starting point. They don't have to think too big too soon, and they can build up to wider solutions. Maybe.
No, I think people. People. A lot of the buzz around this is around big enterprise level solutions. People perceive this as being, not something I can deploy in a normal manufacturing site. It's something for the grown-ups. But how do I start with small steps? And I would always encourage people, we've all, as engineers, we've always collected data. We've always needed data about problems in order to solve them. And if like me, starting in work in the 90s, you'd have plotted that on a piece of graph paper and then moved on to collecting it, on a 3.5-inch floppy disk drive and loading it onto a computer. For me, the first thing is actually look at your problems and look what data is the right leading indicator and what's the most cost-effective way to get that data. The next thing to do is to start thinking about, okay, what are the simple tools that I can use to interact with that data? And if the simple tools give you the insight, absolutely brilliant. You don't need to deploy, really sophisticated tooling. And it's only as you get to the more complicated problems with multivariates that you need to start, bringing those. And that's why I think, that's one of the things I'm always so impressed by with the Senseye solution is the fact you've got, different ways of modeling the data, and you start off from day one with simple thresholds, inflection points, trend analysis. And it's only, as you deploy further and deeper into the customer that you start to bring the more sophisticated tools in when the customer's already seeing value out of the more simple insights.
Yeah. No, it makes sense. And actually, I was just looking at my questions here because one of the questions was about unlocking potential industrial data. And I know RS Industria's got a recent report out as well. So maybe you could describe what was the reason behind that report and maybe some of the sort of findings from that?
Yeah, I mean, the reason we look at these reports and build out these reports is to really help to break down the barriers for adoption around industrial IoT. And I think a lot, so many words around, Industry 4, Industrial IoT are super unhelpful for actually allowing people in factories to think it belongs to me. So, we don't talk about industrial IoT that much anymore. We just talk about industrial data. And we talk about how factories are full of data and machines are full of data. And actually all we're trying to do is make it easier to access the data that already exists and use that data to solve, everyday problems. And I think by changing the language away from some of the hype and back to the everyday terms that people understand from, lean manufacturing and things like that, just makes it a lot easier for people to contextualize how to deploy these tools and how to really get value from it. Yeah.
And actually something Richard said, Rob, sort of resonated a little bit in terms of how to get the data. And I know we've faced challenges, or Senseye Predictive Maintenance has faced those challenges in the past.
Yeah, and there's a tendency to think that, specifically for what we do within that sort of predictive maintenance and condition monitoring domain, that there's a lot of retrofit required, but there's just so much data that's already moving around within the industrial automation networks that you can easily repurpose this. You can implement gateways that can gather that gather that data and do some pre-processing. Because machines are littered with sensors for control systems, and typically a lot of that sensing is quite similar to what you would use for condition monitoring and looking at the health of the machine.
Sorry, Richard.
We always talk about inverter drives within the RS Industria team because inverter drives give you so much insight into what's happening with the motor that's connected to that, and you can do so much condition monitoring with electrical current as the leading indicator, and that is normally an epiphany to our customers when we talk about that, because as soon as you say it, they go, "Oh yeah, I just use it for controlling the soft start, but I'd never thought about using that data for condition monitoring." And the average inverter drive has already got the Ethernet port in the side of it. It's already talking a modern protocol. These are simple devices to get the data out of, and very easy to get great insight from them.
Yeah, and I think the real shift is in the access to the data. So looking at if you were using sort of lower fidelity data like that, because you can see it more often, you're seeing it, almost real time. The type of detections that you're getting, the lead time to failures is suitable. You can be figuring out things maybe days, weeks, months ahead of time. Whereas, traditionally what you'd be doing is taking a reading with using manual equipment once a month. So you need very high fidelity sensing to be very sensitive to change. So there's a fundamental mindset shift as you move into a digital strategy and realizing that always connected piece means it's quite a different way to you to think about the data.
And is it the case, maybe it's too general a question, but do customers you guys speak to all the time, do they sort of overestimate or underestimate the quality or what data they have on balance?
I think most people don't really think about the data they have from, with this sort of lens. It's part of, what we can help customers to do is to really understand the value of the data they've already got, because they just look at it and go, I don't, I'm trying to solve this problem. I don't have the data. And then when you start to play back that they do have it, and so many customers that we go to, they've got a bunch of smart meters that have been installed on previous projects, but nobody's ever taken the last mile and plugged the Ethernet cable into it. And so, my solution engineers will go around and literally they're in people's electrical cabinets going, that's connectable, and that's connectable. And it's normally, amazing insight for the customer when they realise just how much is there for free or for very low cost already.
Yeah. And even, some of the early cases, even just being able to see the data can make a difference without any analytics. Some of the very early wins and success cases that we see with customers, it was within days of just connecting up. You connect up, 50 AGVs in a fleet in a factory, and then realize that why is one of them 10 degrees hotter than everything else, right? And that's just having that end connectivity, like you say, that last piece put in place to let people get to the data and see it. And then you layer on the analytics to start looking at it automatically for you.
Yeah, I was just wondering, do you foresee a time when the customer will be able to see that for themselves, or there'll be less reliance on the vendor to come in and say, oh, you should do this, this, and this? Or, well, I'm not saying it'd be a complete customer side thing, but do you see them taking more control over that themselves and then working with vendors to sort of exploit that data?
I think I see increasingly digitally native engineers moving into leadership roles inside customers. And these are guys who were born with an iPhone in their hand and are just used to the concept of using data and used to seeing analytics in their everyday life, and are much more open to the concept of let's just get the data and do stuff with it. But even then, they need help in understanding the practicalities of how to do it and the mechanics of how to get that data.
Yeah, and definitely, I think we're in a transition stage at the moment, and a lot of this is very new. I think we'll get to the point where it just becomes a standard feature in your factory, and it's just accepted there. There's still work to be done in making these solutions much more plug and play and deployable without sort of delivery support and onboarding support. And this is where you start to shift away from it being the opportunities with maybe the higher sort of larger organizations, to making it something that's accessible to all scales of business, including SMEs and companies with just one or two machines. That should be the overall end vision, that it's just ubiquitous.
And I think the market is not maturing at the speed that people would have thought 5 years ago. So 5 years ago, Gartner would have had it being 5 to 10 years for maturity, and now Gartner have it being from 5 to 10 years for maturity. And I think these are not the technology is there. What it is the cultural change that you need to allow people to embrace the technology, and that's why it's important to be able to start with this small scale proof of value. You don't need to prove the concept anymore. You can collect the data, you can get insight. The concept is proven. It's now about the value creation in your factory for your problem statement.
Yeah, and I think that's fair to say that culture is something we talk about a lot, isn't it, in terms of scalability of predictive maintenance. But I know I'm going to do a plug for our report that's been released next week. Next week. I don't know when this podcast can be published, so hopefully published by the time we talk about it. But can we talk a little bit about that readiness factor for this sort of the cultural change, for deploying technology at scale, as a case with Senseye?
Yeah, so we capture like a readiness index in our sort of sales process with clients, but then it also extends through even after deployment, just to understand how that's evolving. And it looks in two dimensions, really. There's a technical dimension, which is like data readiness, and then there's an organizational dimension, which is cultural readiness. I think what we're seeing in the data that we've collected over the years and talking to many clients and customers, is that cultural piece is still relatively low. We're starting to see more acceleration in the connectivity and the digital piece, but that's really where the emphasis has to go. And this is where from the perspective of what we're doing within the Senseye team, is we've got a real focus on that. I think, as Richard mentioned, the technology is a given. It's how do you support people in understanding how to change their ways of working.
Yeah. And would you sort of concur with what sort of Rob was saying there?
Yeah, I was, reading a report fairly recently about, customers who've got real value out of digitisation, and it was against, and it was looking about people's maturity in lean and their maturity in digitisation, and the people who had the best deliverables, the most effective management of KPIs, the people with high lean, high digital. The people actually who had the worst performance are the people with low lean and high digital. Because if you optimize a process that's not working, if you try and digitize a process that's not fundamentally right, you just end up with an expensive process that's not right. So actually, you've got to get the cultural change, you've got to get the ways of working, you've got to have the domain understanding, and then digitization becomes the accelerator that moves you forward more rapidly.
Yeah, exactly, and it's a sort of industries that we see as where. Yeah, you're right. You've got that pull from a reliability engineering. They're already very, KPI driven at the core of their business. There's you see dramatic differences between, things like heavy industry and automotive at one end of the scale, as opposed to maybe like food and beverage and consumer goods and packaging at the other end of the scale. Where traditionally, within the automotive and heavy industry sector, reliability engineering is a core, and it's a given that it's there. Maybe if you're making consumer products, you're not really thinking from that perspective.
I think one of the other barriers is around, people don't look at reliability holistically. They look at it in the context of the maintenance budget rather than looking in the context of the total P&L. So we've just done a piece of research in conjunction with the IMechE, where we surveyed 700 maintenance professionals across the UK on a number of different topics, and one of them was about the cost of downtime. And so the average we got back was £5,000 average cost of downtime, which feels about right in food and beverage, clearly way too low in automotive. But 20 hours of unplanned downtime, a week. Now, if you think, 20 hours times 5, that's £100,000 worth of downtime, per week, times by 50 weeks a year, that's £5 million worth of downtime. And if you're making 10% margin, you've got to sell £50 million more stuff to recover the cost of that downtime. But people look at it in the context of a maintenance budget rather than look at it in the context of the whole business.
Yeah. And I think on top of that as well, it's like once you start to achieve that increased availability, if you start to do that across many facilities within a geography, you're in effect creating like a virtual new factory, by increasing the availability of the existing factory. So it has massive impacts on CapEx spend as well. And, even, at the CFO level, there should be a high interest in pushing this type of technology forward.
And in the net zero agenda as well, because, machines with low availability consume more energy per unit of production. If you're as a business trying to drive to net zero, and we all are, then actually, driving up availability will reduce your carbon footprint per unit of production.
Please like and subscribe on all major podcast channels, and find out more about Senseye Predictive Maintenance at Siemens.com.